going to talk about extending polynomial identities to complex numbers. Now, last year we learned about complex numbers. Raise your hand if you remember what complex numbers are. How about imaginary numbers? You guys remember what imaginary numbers are? Yes. Okay. So imaginary numbers is what we're going to be using right here. We're going to extend that idea. And we're going to factor polynomial expressions over the set of complex numbers. So you remember that quadratic formula we learned last year? You are going to have to regurgitate that. We're going to be using that a little bit today. Okay, what was that? We did sing a song with it. Maybe if we're lucky, Mr. Lastrite, he'll get up and sing it for us or something like that. So, no? Okay. All right. Oh yeah, Carly's really good at it. She actually, I heard her singing it out in the hall the other day. So, okay, so we'll probably have her sing it. All right. Okay, so factor polynomial expressions over the set of complex numbers. I'm going to give you a second to write that down. Before I get to this part right here, I want to talk about complex numbers, just to remind you guys. You guys all remember this right up here? That little chart right there. What are complex numbers? What does a complex number look like? Has an I on it. It's in the form a plus bi, where a and b are real parts, are real numbers, and I is the imaginary unit. Okay. What does I stand for? Just to remind us, you guys. I equals what? Yep. Square root of -1. That's what I is. Okay. An example of a complex number would be 2 plus 5i. So we have the real number 2. 5i is the imaginary part, but 5 is a real number multiplied by the imaginary number. It makes up the imaginary part. That's a complex number. Now, all numbers are complex numbers. Like 7 is a complex number. Because how can it be written as a plus bi? How can we write 7 as a plus bi? That's right. 7 plus 0i. Okay? That's how you could write it. So 4i, even though we call 7 a real number, but it's part of the complex numbers because we can write it as 7 plus 0i. We call 4i an imaginary number. But how can it be written as a complex number? 0 plus 4i, okay? So even all real numbers are complex numbers. All imaginary numbers are complex numbers. So all numbers that you ever learn about in this math class, or probably in any math class, is going to belong to the complex number system. Imaginaries plus real numbers and numbers of the form a plus bi. Okay, now I'm going to ask you guys a question right here. How many of you guys remember how to factor this? Raise your hand if you know what that factors to be. I'll give you a second to think about it. Okay, wait, hold on. Just raise your hand if you know. I just want to see how many of you know. It's difference of 2 squares. Remember that. Okay, 4 is a perfect square. X squared is a perfect square. Trayson, what is it? That is right. X plus 2 times x minus 2. It's called a difference of 2 squares. Okay, that's called a difference of 2 squares. Anytime you got a minus sign in the middle, and then your first term is a perfect square, which x squared is a perfect square, because x times x is x squared. 4 is a perfect square. 2 times 2 is 4. Then it factors to be x plus 2, x minus 2. I want everybody to take a minute, multiply x plus 2 times x minus 2. I want you to multiply it out so you can see why it's x squared minus 4. Go ahead. Okay, I want you guys in your groups to solve these, or to factor these 4 problems right here. Just factor them. Okay, in your groups, do those 4 problems for the x squared minus 6. Okay, how many of you had that? X minus the square root of 6 times x plus the square root of 6. Can you do that? Yeah. If you multiplied those two back together, guess what you would get? Let's do it. X times x is x squared. X times the square root of 6 is x square root of 6, right? Okay. Negative square root of 6 times x is negative x square root of 6. And negative square root of 6 times positive square root of 6 is negative square root of 6 squared, right? What happens to the two middle terms? They add up to 0, and you get x squared minus the square root of 6 squared, which is 6, because they cancel each other out. And so you get x squared minus 6. So do you guys see that even though 6 is not a perfect square, I can take the square root of it and still write it as x minus the square root of 6 times x plus the square root of 6, okay? I think you guys got these others right. Did you guys get 2x plus 5 times 2x minus 5 for this one? Yes. Okay, x plus 7x minus 7 for x squared minus 49, and x minus 4 and x plus 4, okay? Any questions on that? Okay, that leads us, going back here, we want to now talk about the sum of two squares. Now, this is where we're going to get into complex numbers. Okay, so I'm going to go back here, and I'm going to talk about this one, x squared. I wrote some examples down here. I got to look at them. Let's do x squared plus 16. Okay. Now, what's different about this problem than x squared minus 16? Well, yeah, you got a plus instead of a minus, right? Okay, that's the difference. Now, is it possible to factor a sum of two squares and get real numbers? Think about this. If I was solving this equation right here, x squared plus 16, is there a number I can put in for x, square it, add 16, and get 0? Why not? Say that really loud, Julie. Yeah, if you square something, it makes it positive. So a positive number plus a positive number is definitely not going to be 0, right? You would have to get this to be negative 16 plus 16 to get 0, right? And so there's no way that that's going to work out. So we're going to talk about factoring this, just the x squared plus 16, over the real numbers. Over the complex numbers. So if we rewrote this problem as x squared minus a negative 16, like this, is that the same thing? Are those equivalent expressions? Yeah, minus a negative number is equivalent expression. So I want you, in your groups, to factor that. What would it be? Okay, think about a difference of two squares, because we now have a minus sign right here. Negative 16. You got to think about the square root of that, okay? I'm going to give you a minute on that. Go. I think most of you guys figured out. You guys, if we had x squared minus 16, we all know that it's equal to x minus 4, x plus 4, right? And we did that by taking the square root of 16 as 4, right? Square root of x squared is x. One's plus, one's minus, because we want the middle terms to add up to 0. Well, when we change the x squared plus 16 to x squared minus a negative 16, it's going to be the same thing. It's going to be x plus something and x minus something. But I'll show you in just a second. What's the square root of negative 16? 4i, right? Because remember that 4i times 4i is equal to 16i squared. And what is I squared equal to? We learned that last year. What's I squared equal to, you guys? What? Negative 1. Everybody write this down. I squared equals negative 1. Everybody write that down in your notes. Some of you have forgotten that since last year. I squared is equal to negative 1. Let me put one more step in here, you guys. I probably skipped a step that probably x minus the square root of negative 16 times x plus the square root of negative 16, right? Okay. Remember, when you take the square root of a negative number, it can't be a real number. It has to be, because remember that I equals the square root of negative 1. We learned that. So if you have the square root of negative 16, that's equal to the square root of negative 1 times the square root of 16. Square root of negative 1 is I. Square root of 16 is 4. So that makes 4i. Have we forgotten that much? How many of you remember that now? Okay, now that I showed you. Okay, so you guys, the square root of negative 16 is 4i, so it's x minus 4i times x plus 4i. The square root of negative 49 is 7i. That's right, Tracy. What's the square root of negative 64, everybody? 8i. What's the square root of a negative 121? 11i. Okay? So all you have to do is put an I by it when it's a negative perfect square, right? Okay, so let's do a couple of those. Here we go. On your etch tables, I want you to solve a couple of these. I want you to factor a couple of these. X squared plus 4. X squared plus 25. Do those two. Okay, here's the answers, you guys. Yes, Julie? Yeah, what's I times I? Yeah. I times I times I is the same thing as I squared, right? And remember, we learned that I squared is a negative 1. We learned that last year. Did everybody write down that I squared is equal to negative 1? You should have it in your notes somewhere. Look, I'm just going to show you guys. X times x is x squared. X times negative 5i is a negative 5xi. 5i times x is a positive 5xi. And 5i times a negative 5i is a negative 25i squared. Do you see that? Okay, so what do my two middle terms add up to? 0. And I have 25i squared. What is I squared equal to? So I can replace I squared with a negative 1, so negative 25 times a negative 1 is x squared plus 25, which is what we started with right here. You got that? Okay, everybody, do this. Multiply these two together. Do the full multiplication of that. I know you guys know how to, you probably know the shortcut now. You should know the shortcut, but do the full multiplication just so you can see, and then from now on you can use, after that, you can use the shortcut. Just to check, x times x is x squared. Okay? X times negative 3i is negative 3ix. 3i times x is a positive 3ix. 3i times a negative 3i is a negative 9i squared. Why is it I squared? I times I. Why is it minus right here? Positive times a negative is a negative. And 3 times 3 is 9, right? Now, some of you guys, when you got to that part, you kind of messed up. But what do the two middle terms add up to, you guys? 0. And then I have negative 9 times negative 1 because I squared is equal to negative 1. And what's negative 9 times negative 1? Positive 9. So x squared plus 9 factors to be x plus 3i, x minus 3i. Are we kind of getting the idea of this? Okay? All right, so hopefully we're getting it down. Now, we're going to move on to solving equations. We've been factoring. We're going to use that factoring to solve equations now. Okay? So let's say I wanted to solve this equation right here. Okay, now we just talked about this a second ago. Is there a number I can put in for x and square it, add 4 to it, and get 0? No, because I would have to make whatever I got over here as a negative 4, so negative 4 plus 4 is 0, right? It's impossible to find a number I could do that with in the real numbers. But is it possible in the imaginary numbers? What would be the imaginary number? Not 4i. Think about it. 2i, right? Because 2i times 2i, let's do this. 2i times 2i is equal to 4i squared. And what is 4i squared? A negative 4, right? And so if I went 2i times 2i, so the number that works here is 2i. Because 2i squared is a negative 4, and negative 4 plus 4 would make 0, right? Okay, so let's go back to this. Say that again. Okay, we're going to factor this like we're doing a difference of 2 squares. You guys, I could, okay, I want all eyes right here. I could do this. I could minus 4 from both sides of this. And then take the square root of both sides, right? Plus or minus the square root of negative 4. Well, what is the square root of negative 4? 2i. I could get the answer like that, right? And that's a good way to solve these equations. In fact, it's the best way to solve these equations. But today, I need you to learn this other way because it's going to lead into some other stuff we're going to do. So we're going to use the factoring way to do it. It's a little bit longer. But I want to do it. You guys just factored. What does x squared plus 4 factor into? And x minus 2i. We just learned that, right? Now, when I have a factor times a factor equal to 0, how do I find out the solution? Say that again, Andrea. Yep, take each factor and set it equal to 0, because we want to know what would make each factor 0. And then what do I do to this one? Okay, what would I do to both sides of this one? Minus 2i. And I'd get a negative 2i, and this one over here I would add 2i. And there's my two answers. I don't know if that was probably about the same length as the other one, wasn't it? So, but I want you doing it this way today. Solve it by factoring, okay? Say that again? No, those are two different numbers. One's negative, one's positive. It's like, is negative 2 the same thing as positive 2? If you had negative $2, is that the same thing as having positive $2? No. Well, let's say I was solving x squared minus 4 equals 0. Aren't there two answers to that one? What's two numbers that I can put in for x squared minus 4 and get 0? 2 or negative 2, right? So this one also, whenever you have a quadratic, you're going to get two answers. Whenever you solve a quadratic equation, you're going to get two answers. Sometimes they're going to be repeated. They're going to be the same number. That happens sometimes, but you're going to get two answers. Got it? Okay, so everybody, I have two equations for you to solve. Solve these two. Okay, Going to give you a couple minutes to solve those. Okay, it looks like you guys had the answers there. I'm going to go on to the next thing. All right. Quadratic formula, you guys. Okay. Tracing. Why do we use the quadratic formula? Okay. Let's say I have this equation. We just got to review this really quickly. Why do we use it? Trevor. Oh, but you remember the quadratic formula. But all right, everybody write down the quadratic formula. You're going to need this in your notes. You're going to want to put this on your 3x5 card for the next test. Hey, you guys are good. I know, I remember that now, Noah. Do you want to do it again? Maybe later. You feeling a little shy today or something? Noah's feeling a little shy. He'll do it tomorrow. Friday. Okay. X squared plus 6x plus 10 equals 0. I'm going to have to use that formula. Hey, by the way, how many of you guys have taken have any of you taken the ACT test yet? Raise your hand if you have. Yeah. So, going to this right here, you guys, the question is what is A, B, and C? Do you guys remember what A, B, and C are? So A is the number right here. When there is no number right there, we can assume it's what? 1. 6 is right here, and 10 is right here. That means this is A, B, and C is the constant. B is the linear term, A, or the constant of the linear term, or the coefficient of the linear term, I should say. A is the coefficient of the quadratic term. So all we have to do is plug those numbers into the formula. Now the formula says negative b. I like to think of it as opposite of b. So what's the opposite of 6? Negative 6. Plus or minus the square root. B squared. What's b squared? 6 squared, which is 36. Minus 4 times a times c. What's a? 1. What's c? 10. All over 2 times 1, which is 2. Now, did we have to use the quadratic formula to do this problem? Could we done this one by factoring? Could we solve this quadratic equation by factoring? Are there two numbers you can times together and get 10 and add together and get 6? Okay. 1 times 10 is 10, but 1 plus 10 is 11. 2 times 5 is 10, but 2 plus 5 is 7, right? And those are the only factors of 10, right? So this one's not factorable. So we probably need to use the quadratic formula. Not only that, but I want you guys to look at this right here. 4 times 10 is 40. What's 36 minus 40? It's not 4. It's negative 4. The square root of negative 4, what does that tell you? It's an imaginary number. Do you guys remember the b squared minus 4ac? Do you remember the special name we called it last year? It's called the discriminant. It discriminates. It tells us whether there's going to be 2 real solutions, 1 real solution, or 2 imaginary solutions. What's there going to be in this one? 2 imaginary, because anytime the number inside, anytime the b squared minus 4ac is a negative number, like in this case it's negative 4, then it's going to be 2 imaginary solutions. What is the square root of negative 4? 2i. So we're going to go this way with it. This is negative 6 plus or minus 2i over 2. Will 2 go into both those numbers? 2 will go into both those numbers. How many times will it go into negative 6? And to 2, 1. So the answer to this is negative 3 plus or minus I. Negative 3 plus or minus I. Yeah, I'm going to do another one here in just a second. I'm going to have you guys do one here. So, my solution, my two solutions are negative 3 plus I and negative 3 minus I. Those are my two solutions right there. If you separate them. That's fine. But the reason I'm showing you this right here as two separate solutions is because the next thing I want to show you is that we can write these as factors. Okay? We can write, if we take this equation, x equals negative 3 plus I, and get everything on one side, everything on the same side of the x, what would this one say? X, if we move everything to the left side, what would we get? Plus 3 minus I equals 0, right? What would we get for the other one? X plus 3 plus I, right? That's what I would get. Equals 0. Did you know that if you times these two together, you times x plus 3 minus I times x plus 3 plus I, you would get x squared plus 6x plus 10, like Cole just said. Okay? You would get that. Those are the two factors. If you multiplied those two things together, you would get x squared plus 6x plus 10. Should we try it? Why? Because this is a quadratic equations. Hey, you guys, see that 2 right there on the quadratic, x squared? Anytime you solve a quadratic equation, you're going to get two solutions. Everybody write that down in your notes. Anytime you solve a quadratic equation, you're going to get two solutions. With a quadratic, they're either going to both be real, both be imaginary, or both be the same number, the same real number. Okay, so write this down. Quadratic equations always have two answers because it's degree 2. If you solve a third degree polynomial, guess how many solutions you're going to get? 3. If you solve a fourth degree polynomial, guess how many solutions you're going to get? 4. Okay? And what I want to show you right here is if you're going to get two solutions, you're going to get two factors. And if you multiply those two factors together, you're going to get the original polynomial expression. Okay? This is a lot to take in, huh? Okay, I'm going to have you guys work on one right here. Here we go. Everybody do this one. Solve that equation. Hey, a lot of you guys, when you wrote down the answer should be like this. That's your answer. You guys, we have not taken the square root of 23 yet, have we? You had the square root of negative 23, but we separate that in the square root of negative 1 times the square root of 23, right? Square root of negative 1 is I, but 23 is not a perfect square. If we took the square root of it, it's going to be 4.8 or 9 or something around in there, isn't it? But we're not going to do that. We're just going to leave it as a square root of 23. So that's why this is the answer. Okay, got it? Well, your answer would be this right here. Your answer would be x plus 5 plus I square root of 23 over 2 equals 0, and x plus 5 minus I square root of 23 all over 2 equals 0. Those are your two factors. If you multiplied those two factors together, you would get x squared plus 5x plus 12. All I did is I added 5 to both sides, and on the plus I minused I squared of 23 over 2 to both sides. And on the minus, I added I squared of 23 over 2. Oh, wait. You know what? Yeah, this should be 5 halves. Sorry. Thank you. That should be 5 halves. I made a mistake there. Okay. Well, this is what we're doing right now. What I want to lead this into, you guys, is that every quadratic equation has 2 linear factors. These down here are your 2 linear factors. If you multiply these 2 linear factors together, I say linear because x is to the first power. If I multiply these 2 linear factors together, I would get this x squared plus 5x plus 12. Trevor. Yeah, you could, this would be 2x plus 5 plus I root 23. So if we want to write the 2 factors, that's probably what we do. Times both sides of each of these equations by 2. So we'd get 2x plus 5 minus I root 23. Well, it was a negative 5. When I went to the other side, it was negative 5 both times. The plus and minus is over here. So it's going to be a plus when you move it to the other side. Okay? And if you multiply these 2 things together right here, you're going to get x squared plus 5x plus 12. Those are your 2 linear factors. All right, now, I gotta go back to what we were doing earlier. I had you guys solve this just a little bit ago. What was the answer to this again? What if I gave you this? Everybody solve this one right here. Okay, this is what Taylor got. And that is correct. X equals I squared of 5. X equals negative I squared of 5. All right. You guys, your assignment today, I pasted a website to my website, a link to a website to do your homework on. Okay, so let me show you this. Okay, so you guys all go to the Hurricane High School website. I'm going to show you where your homework is. You go to departments. You go to mathematics. Okay, are you guys paying attention to this? Okay. You go to my name. Go to personal website. And you are going to go to Secondary Math 3 Honors, Period 2A. It's the first one. And right here, you guys, here's the videos that I've done in the class. I haven't done one for a little while. Today, there's going to be one, in case you forgot how to do this. Right here, it says quiz assignment link. Everybody write that down, quiz assignment link. If you go to that link right there, see it works. So I just proved to you it works. Okay. It takes you to this website. And there are, it gives you an explanation of what I just explained to you. And then there's a quiz right here. You'll notice it gives you the answer to the quiz. And an explanation at the end of it. Okay? So, but here's the deal. This is your homework assignment. There's 10 questions. There's 10 questions on this assignment. I want you to make sure you understand every single one of them. So try to do the problem yourself first. Then check to see if you got the right answer. If not, read through the explanation. And even if you did get it right, I'd read through the explanation to see how they explained it and see why the answer is what it is and see if you got it right. Make sure you understand all 10 problems. When you come to class on Friday, we're having a quiz on this stuff. Any questions? I want you to write it down. We're going to turn this assignment in. You guys, you have to write these problems down. And I don't want you to put A, B, C, or D. Listen, don't put A, B, C, or D. I want you to show me your work and then show me the answer. All 10 problems. Show me the work, show me the answer. Now, there's no excuse not getting this done because the work is already done right here. It shows you in the explanation how to do each problem in case you can't do it. But I want you to make sure you do it. What are we doing on Friday when you guys come to class? We're going to have a quiz on these problems. Make sure you know how to do them all. Okay, now I got to talk about something else. Make up for the test.